And we are back. So we got a preview in the last segment, but in this one, we're going to discuss in a little bit more detail why we've chosen to use Python for this course. Okay, so no language is perfect. A great quote on this is from Bjarne Stroustrup, the inventor of C++, which, if you remember the previous segment, is a compiled language. And he said there are only two kinds of programming languages, the ones people complain about and the ones nobody uses. Let that one sink in. So like different Swiss Army knives, to bring back that analogy, each language has its disadvantages and its advantages, but at the end of the day, they're all fundamentally very similar. And that actually goes back to the notion of computational universality, which is what I mentioned earlier. That basically says that any programming language could simulate any other programming language. And what that means practically is that once you learn one programming language, you can learn almost any other one fairly quickly. But why Python specifically? So for one, it's free. That's actually a really big deal. So as a comparison, MATLAB, which is another common scientific programming language, requires software that costs almost $900 a year if you're not part of an academic institution that buys it. Now, there are a lot of people outside academic institutions who just can't afford that. So when you write MATLAB code, you're unfortunately ensuring that your work will be inaccessible to a lot of members of the scientific community. That's just not good practice. So another thing, Python is open source, and that means that there's a large user community, mostly volunteers, who are constantly fixing bugs and improving the language. And again, as a comparison, with MATLAB, you're at the mercy of MathWorks, which is the company that sells it. And MathWorks, sometimes they might have their own priorities based on what's most profitable. Next point. A lot of people don't realize that Python is actually pretty old, which means that its core functionality is rock solid. And that means that people trust it to work reliably. And it's general purpose, which means that it's good for science as well as tasks outside of science, like software development or web scraping. And because it can do so much, the skills that you learn this quarter should be transferable to just about any job that uses Python. And of course, it is incredibly popular in science. And that means that scientists have created a giant ecosystem of packages for Python. A package is basically a library of code that extends the core functionality of the Python language. We'll talk more about that soon. And lastly, a lot of Python's popularity is because it's one of the easiest languages to teach and to learn. It's a big reason why we're using it in this course. So how popular is Python? By some metrics, it is the most popular programming language at the moment and rising quickly. So to illustrate this, this graph shows the fraction of total questions posted for a given language on Stack Overflow, which is basically like a public Piazza Q&A board for programmers. Python here is this blue line, which just a few years ago has finally eclipsed all the other languages. It's worth pointing out that the language R in purple down here has been steadily rising too. And you might encounter R if you do more biological focused or statistical research, which it's really good at. I should say though that while R is great at stats and biology, there are not a lot of things you can do in R that you can't do in Python, which is one reason Python has been embraced by every corner of the scientific community. But to reiterate, no language is perfect. And that's it. This is a short segment. We'll be back soon.